Okay, so good evening, everyone, and welcome in this IEEE Education Week celebration under the banner of IEEE Signal Processing Society Gujarat chapter. So, as we know that IEEE Education Week is just a week-long celebration of educational opportunity that provides by the IEEE. And this year, IEEE Education Week is celebrating between 14th April to 20th April. And today we are celebrating our IEEE Education Week with the expert Dr. Ramkumar Rajendran. He is the Associate Professor in the Department of Educational Technology, IIT Bombay. And as per this particular thing, as first I need to introduce Dr. Ramkumar. So he is the Associate Professor in the Interdisciplinary Program in the Educational Technology and the Center for Machine Intelligence and Data Science, CMINDS at IIT Bombay. And before his current role, he worked as a research scholar at Vanderbilt University and as assistant manager at NEC Central Research Laboratory in Japan. Dr. Rajendran research interest spans in the learning analytics, effective computing, educational data mining, intelligence learning environment, self-regulated learning, MOOC data analysis, NLP, and deep learning. And Dr. Rajendran received a PhD from IIT Bombay and Monash Research Academy, IIT Bombay, India, and Monash University, Melbourne. I think that is the just collaboration between IIT Bombay and Monash University, Melbourne.
Yes.
And he served as a program chair and track chair for various international conferences, including LAG, T4E, ICLT, ICCE. His research has garnered by support from funding bodies such as the SERB, IHAB, and the various educational foundations. So I welcome Dr. Rajendran. So he can start his talk on the exploration of AI on the educational technology research area.
Thank you.
Welcome, Dr.
Thank you,
Rajendran.
Manish. Yeah, thanks for the invite, firstly. And this is new for. Yeah, can you see my screen?
Yes, sir.
Yes.
Yeah, thanks for the invite, and I think this will be new, but I'll just keep it. The intro level of what we are doing in the AI in education. Then I'll talk about a couple of projects we do. I think that is the goal, and I hope I can motivate most of you or some of you in this group to take research in education technology. Also, you might think education technology, when we think here this word, we think about the BA or MA kind of education, mostly pedagogy, but I was going to show something is beyond that also is needed. Especially we need people from a different background, signal processing and computer science students. We need them to in this particular domain. This can be one of the application area. I just want to talk about this today's talk. I'll keep the talk for say 45 to 50 minutes, then I'll keep the last 10 minutes for any questions. But if you have any questions in between, please unmute and ask me. Since I'm sharing the screen, I'm not able to see who's chatting in the chat box. If someone can help me to summarize the chat messages, that would help a lot.
Yes, sure.
Okay, thank you. So to start, myself, Ramkumar Rajendran, I'm interested in education, learning, analytics, or intelligent tutoring systems, focused on understanding people, affective states, self-regulated learning, so that we can provide a better feedback. I'm a faculty at EdTech department in IIT Bombay. I'm also associated with the department called Center for Machine Intelligence and Data Science at IIT Bombay. So I'll just briefly talk about our department before we jump into this talk. Education technology, you might think, IIT, what is they doing with EdTech department? EdTech department started like 12 years ago. And with the aim of developing some research problems around EdTech for PhD. Recently, we started MTech. There are 4 major research areas you work on. The first one is TLEAD, Technology Enhanced Learning of Disciplinary Practices. In this particular group, we develop technology enhanced learning environments to train the students on one particular pan-domain thinking skills. The thinking skills can be estimation, engineering, or convergent divergent thinking. Those kind of pan-domain thinking skills we like to train the learners by developing a learning environment. The other research areas that teacher use of education technology. We work on tools which will help the teachers to use them to improve their education or the teaching quality or pedagogy, all things. The third group is what I belong to, educational data analytics, where when we create a technology enhanced learning environments, we collect a lot of data from that. We would like to analyze those data and understand the students' learning processes. The last group is emerging technology, where the students were given latest technology like a sensors, 3D printers, or eye gaze trackers, or the personal robot, or an 360-degree camera. Those latest gadgets is given to the student. Also with their tech concepts, they have to think about one new methodology or pedagogy to develop, use this particular environment to teach something new topic. So this is basically trying to use emerging technologies to improve the education. So as apart from this, department also works on MOOCs and develop latest tools for support education and teaching learning process. The more on this is in the et.iitb website. Also, we do a lot of consulting and sponsored project. So we're a very small group. It's started in 2010, and 6 core faculty, few PhD students, around 40 students are there now. 25 students have completed PhD. We have a program also. So before we start, I want to all of you here take your phone, scan this particular thing, or go to menti.com, MENTI, and enter this code 47178888. Can you do this? So I'm going to start the presentation. You can go join at menti.com. Then you can go to menti.com and enter this code 471787. What I want here is that think about what is learning. I think we are going to talk about learning, or think about how do you learn? What is learning as per you? Like, what is learning involves? Of course, learning involves you have to go and read something. Learning involves you have to solve some particular task. But what is learning? Is it a planning? Is it checking the task done correctly or not? What is this learning? Can you think about what is learning according to you in a 3 or 4 sentences? That's a 3 options are given. You can fill one, it's not a problem. Or think, how do you learn when we're given a task? I'll wait for 2 minutes here till 4:11. There are around 70 plus participants. I would expect at least 40 participants can answer you. Okay, I'm seeing some 3 members side, so I'll wait till 4:11, right? I just mentioned it. Okay, I will check. Okay, so 30 people sends it. I would expect more people to choose this. Okay, since there are around 15 to 20 members answered, let's look at the slides. Okay, there are a lot of people entering now. I think I should give one more minute. Okay, why is this saying? Okay, so here, interesting. So to know about the thing, to gain something, knowledge in the form of self motivation. I'll just write down the words motivation. Learning involves motivation, right? We might want to learn something, but we fail. Still, we continue because there's a motivation, and you have to understand that's a major one. Learn by experience. You have to learn based on your prior knowledge and prior experience, apply it in the current term and learn it. Learn by experience, learn by motivation, and mostly experiences are there. Then process of understanding, process of getting a new knowledge of new things is learning. Learn by watching, learn by reading, learn by memorizing. These are all fine. So when you learn something, this is how it shows you. Let me stop. I'll go back to the slide. I think we can stop for a minute. I think 24 minutes. Now let's think about learning. When I ask any of you here to go and find a paper related to signal processing, the latest state of art in signal processing paper in say a particular filter or something like that, the step you would do is that you would go to the so initially what you would do, you would think about it. To find a paper, I will go to Google Scholar. Then if Google Scholar, I use the keywords like state of art, signal processing paper, some keywords, you would use it. Then you will read it and you'll find a paper. That is your plan. So before if you do this task, you got a plan in your mind saying that I'll go to the particular resources and do it. This plan comes based on your prior knowledge or prior experience, that is learned by experiences. Once you go to the Google Scholar, then start typing this particular keyword, you're looking at the papers, but none of the paper matches what you're expecting. Then you have to refine your keyword. You start refining the keyword, again search again, then it doesn't work. After spending say 10-20 minutes, you feel this particular strategy of going to Google Scholar is not working to find the latest paper. Then you think about other strategy. What is the important journal or the conference in this area? Then go to that conference and look at the latest papers, or the journal latest papers, you look at it. So the second strategy, even if it doesn't work, third strategy, go and talk to a mentor, go and talk to some expert in this particular field. They would be able to quickly tell you what is the paper about. So firstly, you created a planning. After the planning, you are executing it. While executing, you're trying to understand whether it is working or not, whether the paper meets your particular criteria which you set yourself. Then if it is not working, you rechanging the keyword. All this thing happens in your mind. You have not written this anywhere in a notebook or anything. So learning always happens like this. You plan something in your mind without even you understand. Learning any complex task, you execute it, you observe the outcomes, then you are aware that the outcomes are not working, then you change it. That is called metacognition. That is called metacognition. So someone entered that learn by experiences and metacognition. So I'm going to say, what is the learning? Learning people involves cognition. Cognition means the ability to read, search, and everything. Metacognition involves planning, awareness. Also, learning involves affective states. Affective states, like you might search a lot, you might work a lot, then you are not finding it. You might bored, you might get confused. That's also very important, so that how you cope up with these emotions then continues also involves in the learning. The last somebody wrote motivation. There are a lot of students here. You would not want to take any particular course in a semester, but still you are doing this course. You don't like that course, but still you are doing the course. I don't know the course name. Maybe the very popular course in our time, digital signal processing. And a lot of students don't want to take the course. Still, why are you taking that course? It's because that course has the value is connected to the degree. If you don't complete this course, you won't get a degree. So the particular course has the value, that is a task value, or that's called connected to the motivation. So motivation can be come from your own motivation, or the motivation come from task value, or the value of this, your self-efficacy, all these things involved. Without going in detail, I'll go and ask a second question. Now, in the second question, I want you to think, how do we measure How do we measure learning? Now, I spent almost last 3 minutes explaining what is learning. Learning involves a lot of tasks, like you have to plan, you have to organize your thoughts, then you have to you have to execute it, and you have to redo the task, and if not working. Now, in your setting, current setting, how learning is measured? The good answer is quiz. People saying, I measure the learning by quiz. What are the other metrics we use to measure the learning in current setting? Quiz, exams. Yeah, hi, hello. Somebody says hello on both sides. Good. Um, how do we measure learning? The measure learning can be by application. Application is that you're asking a set of question paper to them, ask them to apply the knowledge they learned on this. That's also good. We measure learning by outcome, right? Outcome of exam, outcome of the skill, outcome in the project, presentation, evaluation, quiz, outcome, yes. Assessment, yes. Assessment is the key. Assessment, quiz, evaluation, correct. Assessment again, testing, by doing testing. Okay, nice. Nice. We have 20. I think I'll stop here. Interesting. So now let's discuss. When I explained the learning, I did not talk about the end product. I talked about the learning process. When I ask you to do some particular task, we immediately go to the particular planned approach, a strategy based on our prior experience. Then we try to execute it step by step, and we try to redo it unless we succeed in the particular task. Or if you get bored, if you confuse, you drop the task, you go for new task. But none of this task is mentioned is talking about the outcome. It's all yourself directed and you're able to do it on your own. So this is, but in our current system, we measure the learning based on that, like a test, quiz, all those things. Now the question is that how this particular, learning can be measured other than the assessment. If assessment is not the right thing, assessment is measuring the outcome of the learning. If I want to understand the learning process, how the student is interacting with the system, how the student is, learning, how do I measure it? That is a question I want to ask you. If anyone have an answer, they can unmute and ask. So is it clear? We usually measure the outcome, not the learning process. The learning process involves a lot of things like cognition, metacognition, affect, and motivation and everything. But we ignore them. We just only worry about the test or the assignment or the quiz or something like that. If I want to measure the learning processes and try to understand where the students having struggle, I want to give a feedback or support at that point instead of waiting till the last. What can I do? Can you somebody give the how to do it? You can unmute and speak. Yeah.
By applying it on practical problem solving.
Okay. By giving a practical problem solving, then you will be measuring their outcome, right? Or
Solving process itself as well as the outcome.
okay, you will be observing how they solve the particular process, the steps they conduct. Yes, thank you. Anyone else? I need one more answer.
Something as a continuous evaluation.
Yes, continuous evaluation is a good one. Continuously you can, instead of a summative assessment, you can do the formative assessment like every week or something like that. But there are a lot of teachers here, when the students are in the classroom, when you are looking at them and they are not interested in the lecture, what you would do? That is also one of the assessment, right? The observation you are doing in the classroom, you're looking at the students, and there are students are not interested, students are not focusing. We have to intervene and do it. That is also assessment. You are trying to assess the learning process. The students are confused, the students are bored, they are not interested in this particular task. We have to bring something to them. Like that is also a kind of assessment happens. continuous assessment is another one, continuous monitoring, that is called formative assessment. So I'll go back to,
Hello.
yeah, sorry.
Yes, sir. By giving the some real life examples so that they can connect the particular subject with the means different subjected as subjects that they are studying in a particular semester, as well as means the life learnings we can also include for a technology perspective how they are improving, so that this type of things the students are getting more involved in the classroom.
So you are saying give a real life or practical
Yeah,
problems, or
yes,
let them explore. Let the students explore. Hey, you can take any practical problem. You can apply the things you learned in the semester, 4 5 subjects together, create some solution. Right.
yes, yes, yes,
So the only thing is that it's a very good process, and when students will be struggling a lot because they have to apply first time, they are doing project and combining things, we will be monitoring them and kind of giving support. That monitoring is what I was looking at. Okay, I'll go into how do you measure learning? Basically, assessment, like a summative, formative assessment. Or we can do projects like performance in a particular task, or we can ask the students to self-report. These are the methods we usually do in the classrooms. Or we conduct a standardized exams which measures the students, performance, country level or the global level measurements. We can do standard exams, or we can ask them to provide some seminars. Say, go and read some 10 papers and synthesize and present seminars of that. You can understand their ability to synthesize and everything. Or the measurement can be measured by using research publications too. But if you talk about how they achieve this particular thing, we will go back to this three things I talked about learning. I'll go in detail about what is cognition. Cognition is a mental process. It's kind of a learning, and it's cognition is a process which comprehends to experience and thinking using the senses. For example, a student ability to go and search in Google Scholar is a cognition. A student ability to find a keyword for the given task is a cognition. For the 3-year-old students, or for the 3-year kid, able to identify the numbers is a cognition. For 4-year-old kid, the able to add 2 3 numbers is a cognition. So cognition, everything which you are able to do it, it's a cognition. It varies based on the different age group and difficulty level. So ability to sentences, ability to speak, it's also cognition. So we have a lot of cognition process happening in every step. Whenever reading, looking at it, recognizing the letters, recognizing the words, combining it, comprehending together, we are doing a lot of cognition. But how do you plan this cognition? It's called metacognition. So to understand the cognition, we have to use some think alouds or simulated recalls. But this cognition is not can be measured only by using the exams which I talked about, assessments like standardized exams or self-reporting will not work. So in order to understand this, how students cognate, how to process the information, how they metacognitively think about the problem, we want to understand the trace data. When I say trace data, a data which help me to understand how student would have come to the solution. The trace data should help me to recollect or replay whole process the student did from the start to the end. To do the trace data, there are a couple of ways. Consider the computer-based learning environment. Consider we talk about, I'll just go to a different type of environments. Let's talk about computer-based learning environment. If the computer-based learning environment, if a student is looking at a particular environment and is interacting with something, if I have an eye tracker can be connected to the computer in the in the monitor. And if I have eye tracker, I record the screen, I'll be able to find out where the student is looking at, what are the process they are doing, which image is looking at what time, and what is the next step is doing it. Is able to connect the given data with the question and answer. If I give a multiple choice question, is he reading the question and looking at the options? Is he going back and forth? All those information can be identified only by using the eye gaze data. This eye gaze data can be created by the webcam also. Or if I have a ability to capture the clicks in the computer based environment, like what are steps they do, first step, second step. If I'm able to ability to capture that, I'll be able to capture the time they spend on reading. Are they reading a particular content? Are they watching the video? If they're watching the video, are they watching in which speed? Are they watching with the subtitle? When are they playing? When are they pausing? Are they replaying it? Imagine I have this data. if I have a data, for example, a student is reading a particular content, then went to to answer a particular set of questions. If the student is not able to answer questions, he comes back to this reading the content again, then he goes back to question and answer. So by looking at these actions, read this particular page for this many seconds, assessment, answers wrong, going back to same read content for these many seconds, again assessment, will give you the idea that student is trying to understand this particular topic, is putting effort to go back to read it. Whereas the other student who does not read directly goes and addresses the answer. If he's not answering, he's going back to next question, not trying to read or improve his knowledge, which tells about the students. This is simply by the logging their clicks in the computer. So by simply clicks logging or the eye gaze data, we can recreate or replay the learning processes. This is what I am interested in. Instead of measuring the outcome, we are trying to measure the learning processes. We call this data as a click stream. We record this data with the three key points like a timestamp, like when the particular action occurred, the action they are doing. It can be reading, watching the video, it's a quiz, simulation, or in the project they are writing a code, compiling, error, they are some circuits, they are doing some prompts, those things, and the user ID when ID to identify students, and the context when they're doing an action called reading, which page they're reading, if they're watching the video, or they're watching again, or they're watching first time, or they're playing, pausing, or they all those contexts will help us to understand more about the learning. I hope it is clear till now that we wanted to measure learning, not just outcome. In order to measure our learning in a computer-based learning environment, I want to capture all the interaction a student does with the system. So that is the first thing. Let's talk about metacognition. We talk about cognition. Metacognition, according to John Flavel in 1990s, it talks about metacognition consists of both metacognitive knowledge and experience regulation. Somebody wrote based on the experiences. So when I ask first thing to about it, go and find a related paper in the state of a paper in the signal processing, the first thing comes to your mind is Google Scholar, because you are experienced in Google Scholar already. So metacognitive experience comes into picture. He calls metacognition as a process of thinking about thinking, or cognition of cognition is metacognition. It is about awareness and understanding of one's thought process. But metacognition is not what John Flavel talk about it. For example, if I'm given a task, what should I do? What sources do I have it? What should I want to learn? How to proceed? How long will it take? Where to find the information? Is the information really relevant? After you finding relevant information, is it really correct? It's awareness happens. Then you're trying to read it, then you remember the topic. It's otherwise called as you're planning, controlling, regulate, monitor, aware, reflect. This is called metacognitive strategies. First you plan, then you try to implement that particular thing. Your plan is that I want to go and check in Google Scholar and find related paper. That's a plan. Then you are regulating it, implementing it. While doing that, you're monitoring in the back of your head that is it working? When you look at the paper, it's not the paper you're looking at. Awareness strucks in, then you have to reflect on it. That's the same thing. Orientation the goal, planning, search and judgment happens, extraction the process, then you evaluate it. So this is called metacognition. I think I will not go deep into this process. The two things which talked about is one is cognition. Cognition is your ability to do a task, even a read, search, all this thing. Metacognition is how you're able to arrange this your cognitive ability in a order structure to a particular task. The third one is affect. Affect, when you say that a student put a lot of effort on submitting a particular assignment, still is not able to submit assignment by the end of the deadline, the student will feel bored. Student will feel frustrated. I put a lot of effort to do this particular assignment, still I'm not able to. But there should be something a student is continue to do. So when you say affect, it's kind of basic emotions comes into picture. The emotions like 6 basic emotions by Paul Ekman and Navarasas in Indian context is like joy, sad, disgust, anger, fear, surprise, or with including 3 other things from Navarasas. These are the basic emotions a human expresses it. But while reading, we don't see these basic emotions. We call emotions, which is very critic about the learning environment, that is called boredom. The students are not interested in the current problem, or they are over challenged, or they're under challenged. When you are under challenged, you might get boredom. When you're over challenged, you try something, you try to solve the problem, still you're not able to, you might go to boredom. Confusion, when you are not able to solve a particular given task or you're not able to understand the solution, you might get a confusion. And disgust is annoyance, irritation with material and abilities, and you're not able to solve this. Disgust is the most negative form. I mean, I think not easily we get it. We might get confused, frustrated, boredom. That happens mostly. Frustration is the difficulty with the material. You are trying to achieve a problem. There's something comes up with the not able to allow you to succeed the problem. You might get frustrated. The other one is surprise, and you did not expect the result, but you got a fantastic result, or you expected 80 marks, you got only 30 marks. Those kind of surprises. It's going to be both positive and negative. And there's also a delight, happiness. Also, sometimes you get enjoy in the mood. I'm not telling frustration, confusion, boredom is necessarily negative emotions. Everyone will go through this confusion and frustration when they're learning new things. When you are, if you're not getting frustrated or confused, you're always delayed, you're always able to solve the given problem, which means you are not learning anything new. You are just learning what you already know. If you're learning anything new, you're adding a new knowledge to your existing knowledge, you would feel frustrated, you would go to confusion. Everybody does it, but some students attribute these effectives or these emotions to the external factors. Hey, this topic itself tough, it's not just me, almost all my friends also facing the issue, or this particular math problem is very problematic for almost everyone, it's not me. You attribute your failures, that is not able to understand what's going to do, external factor, keep continuing it. That is how the people do the emotional intelligence. They try to understand those, they keep continuing it. Boredom and delight discussed all kind of bad emotions. We would not let the students, if the boredom, we don't want them to continue. Instead, we want them to take a break and do some other task and come back with the more details. That's the idea we go. Okay, so how do you measure the effect? We can measure the effect using gesture. That is, how the people the stand or the gesture, posture. The facial expressions are very good way to measure the emotions. For example, smiling, frustration, confusion. A teacher does a very fantastically find out how many students are bored, how many students are sleeping from the facial expressions. We can do the voice modulation. Here, the students struggle when they were when they're in fear. The writing patterns, the words they use it. All these things can be able to help you to measure the affective states. Or we can simply use the computer vision to detect the affective states. That's the idea. So till now, I talked about three things. One is cognition. Cognition is about ability to do a particular task, and cognitive cannot be measured by directly from the test. Instead, we can measure the clickstream data, trace data. If you know what are the things they are doing in order to achieve the task, we can measure the cognition. Like he's reading correctly, he's able to convert this reading to knowledge. They are doing something. Metacognition, of course, metacognition is not easy to measure because metacognition happens in the in your brain. The only way to measure metacognition is ask them to think aloud. When you're think why you're doing this step. Asking interviews, why you did this, why you're not doing it, what are the tasks you think about it. So that is the only way to do it. Affect can be measured by using gesture, posture, and other data. So one channel data, that is only log data, eye gaze data, is not enough to understand the learning. Learning is a complex process which involves cognition, metacognition, affect. I'm not talking about motivation because it is not easy even to understand for the human person to in a shorter period. So we're not talking about motivation. So learning, we try to combine these three tasks to measure it. And to measure this, we can't use it to only one channel data, that is log data. So, or the facial expressions, we need to combine it. When you combine a data, it is called multimodal data or multimodal learning analytics. So I'll show you a couple of examples which we do multimodal learning analytics to measure the this cognitive affective states in the classroom environment. So to summarize, trace data is very important to understand learning process. To understand metacognition, we need to understand sequence of keys, temporal aspect of these keys, like are they reading first, are they going answers, coming back to reading, the strategy changed. Patterns has to be emerged. We can do the sequential pattern mining. and we have to create, construct action logs, or you can use this to measure the affective state. You have to use this facial expression, gesture, posture. So to measure metacognition, you can apply the pattern mining, sequential pattern mining, or differential sequence mining to understand this. So I will show you a couple of outcomes. How do you do it? So to understand this, we use the meta multimodal data. We use eye tracker, face cam, wristband, and headband like EEGs, and we collect all this data when students interacting, and we try to understand it. So this is one of our student. He has the webcam. This is the webcam to record the facial expressions, of course. Here it's the eye tracker, which has a 2 infrared LEDs, 1 camera. It is able to detect your people and try to understand it. The person is wearing the GSR. It's a galvanic skin or electrodermal activity, which kind of measures your skin conductance. It will tell you your basically the cognitive load. Are you facing difficulty? Are you facing easy questions? What is your feeling about it? And also log data. By log data, I mean it can be the eye gaze data or all the clicks a student is doing in the system, the click stream data, which we used to collect these things: cognition, affect, and metacognition, which could be able to understand the learner model, and personalized adaptation is the last solution we want to do it. So this is the whole idea. So the learning is not just the outcome, but also a lot of process goes through into it. So if we wanted to understand the learning processes, we need multimodal data. Only one data is not enough. Okay, but most of these things I'm showing here not scalable. For example, EEG, GSR is not scalable. So we will only use the sensors which are scalable. For example, the camera, the webcam, or the voice data, or just log data. We can be, create web-based systems. Anybody can. That's why called ears and eyes of understanding learning. Only voice or eye gaze data. Today I'll talk only about eyes, that is computer vision. So our solution is that different learning environments, we want to talk about it. Let's talk about computer classroom environment. I'll give 2 examples in each environment. I'll stop it after that. We use computer vision to detect behavioral engagement, cognitive engagement, and affective engagement. So when we talk about behavioral engagement, it is just you are present in the class or not. Like as of now, a lot of people are present. I don't know how many of you are actually present. You're present here, which means behavioral you are here. Your attendance is a behavioral engagement. Cognitive engagement is that, are you following me? Are you listening to me? Are you able to create something? There are 4 types in cognitive engagement. Passive. Oh, there are a lot of spelling mistakes in this slide. I just noticed today when I was talking. Passive. The passive engagement is something that when somebody is teaching, you are in the classroom, you're just nodding head. Yeah, you are actually, yes. But you are not, you might be passively engaging. You're not even doing anything actively. In active engagement, a student is nodding and trying to create a notes and following it up with the speaker and trying to create a notes. That can be the active engagement. Constructive engagement is that you learn something, you add on it to the existing knowledge. You might be creating a map, you can be creating some structure of your knowledge, or you are solving the given problem. A teacher thought a problem on, Pythagoras theorem, giving the second set of sums. You're applying the knowledge you learned and solving the problem, you're constructing something new. Interactive learning is the highest form of engagement, and we believe that is the highest form of learning. That is, you interact with your peer, your teacher, or your resources. So we feel learning happens mostly by interacting with peer. So these are the 4 types of engagement. And affective engagement is basically, I was talking about boredom, confusion, frustration, and affective engagement. I'll show you a couple of videos on what you do in the classroom. So before that, this ICAP, ICAP is the framework developed by the cognitive engagement for the classroom, but we also use it for the systems also, like computer-based learning environment. This is passive. This is interactive. This is also interactive, but this is a positive interaction. This is a negative interaction. Head in hand, it's just a passive engagement. Just maybe approach posture, listening to, without doing anything else, listening might be better than heads in hand. Taking notes is kind of active, and raising hands and asking questions is kind of more constructive and building on it. Explaining something to others is interactive, and reflecting out loud is the interactive. Whereas this is also kind of active. You're gazing away, you're not looking at it. You are playing around with things, walking around without intention to interrupt. These are not interactive, but they are not in a positive way. So we would like to measure these things. To do that, what we did, we recorded a video in our classroom. This is our learning analytics classroom. With the consent of all the learners, I collected the data. I told them this data will be shown only in the research talks, not anywhere. So yeah, I have the consent. So I'm going to show the video. You can see the computer vision system detecting the listening, gaze shifting. I'm not sure what is this. Using some material. It's computers using material, and gaze shifting, listening, gaze shifting, taking notes. Let's play this. So that's the simple idea of detecting, interactive, constructive, active, passive. What we did, we just showed here using this box we created using the, CVAC tool. What really happened is that we trained with this particular models with each phases zoned in. We tried to train with multiple times. Then we tried to use it to predict their ICAP framework in a classroom. Because that's the very idea of this particular task. I'll show the second video. Okay, I'll just play it again. I think it's playing. You can check. I hope the video is visible, right? Yeah, okay. Somebody ping, but I can't. Okay. Now, this is affective computing in the lab environment. This is by Ashwin, not from me. And this is a lab environment, and students are interacting with the lab. I'll play it, then I'll tell you about this, how the system works. This guy is sleeping, is engaged 0.99, engaged almost 1, engaged 0.35, 0.3. Discussion is happening. They are discussing, discussion, engagement. This person is walking. Okay, here we did not see the face. Instead, we saw the posture, this hand, posture, and head. We did not need to see the face, it's not needed. The face is important here. When the student in upright position and chin up and doing something, it's engaged. And if the monitor, something is moving in the monitor, changes, because it's a frame. What we did, we take a image, we convert it into 25 frames per second. If there's any change in the frames, we call it as a highly engaged, because it's not just sitting, right? That's why there are some people who are just sitting, they're not engaged because their screens are not changing. If in a particular frame, you just create a multi-frames. If then a frame, two people are coming together, it's a discussion. This person is kind of indicators is sleeping for a second. You just look at carefully. This person is yawning a bit. That's why it's scanning. This person is properly sleeping. That two discussion. Here, this person is not on the screen. He'll come back here later. That's why we can't detect it. That's another challenge. And the challenge is that you can't detect much of things here. We ask the students not to use mobile phones and not to eat in the lab. Otherwise, that else can be detected. I'm playing it again. Yawned a bit here. Okay. So what we did, we saw two videos. The first video about in a classroom, we can measure the ICAP, interactive cognitive. In the second video, without using the face, we are able to measure their discussing position, their collaboration, all this thing. But I'm not showing anything about the affective states. That is also there, but not as a video, but that also we can detect using facial expressions. In this video, I talk about, this is a collaborative class environment. The 9 students can sit in each table. The 45 students can sit in this room. I'm teaching something, the students are here. This particular person is walking. Just watch it. We can run a multiple kind of algorithm on this, but just. So I'm just working on it. This here talking about the kinesthetic movement, like how they are able to move, how the body is moving. These people are not moving. This person is highly active. This person is kind of semi-active. These are kind of not active. That is a kind of a thing. The same video can be used to detect the face, can be attendance, can be used for, used to do, can be used to understand their the task they're doing, the names. interaction, everything can be measured. Okay, till now I talked about cognitive engagement, that is ICAP, interactive cognitive measurements. It can be behavioral cognitive, or it can be the cognitive engagement, behavioral engagement, cognitive engagement. To do the affective states, we have to show the facial action coding system. Facial action coding system is developed by Paul Ekman for the basic emotions. Here they classified each and every the unit, each and action units in our face. For example, eyebrow, left eyebrow, right eyebrow, lips, nose wrinkle, chin, everything is actually captured. Based on these actions in each of these action units, we're able to measure the students' affective states. So we use this computer vision annotated labels. We try to annotate 300 to 400 labels for each of these emotions. For one student, we do it for 30 students, then we train the systems. But the challenge is we are not able to generalize it. We have a lot of models developed for the faces in the West or the Chinese faces, but we can't apply in India because each one depicts the affective states differently across the country. We have fantastic data set in India called the DAISY data from IIIT Hyderabad, but that data set is for the undergraduate students. We are not able to apply in the class 6 students. So generalization is a big problem. That is detecting the affective states like boredom, confusion, engagement by using facial expressions for learning and or any teaching learning is not a possible task. We have to do it again, everything like annotate, train. That is a big challenge. I think anyone is interested in it, you are excellent, please go and do this particular task. So the other one I'm talking about is eye trackers. Eye trackers also would enhance our understanding of learners. I'll show you a couple of eye tracking environment. The green circle represents the fixation on the photo on the beach. You can see they are fixated on this beach. So if I give a photo, ask somebody to look at it, they looked at these places. Or this is the scan path or SACAR. A student started from here, he looked at this page here, they are spending some time. If they're spending more time, there's green bubble is bigger in it. If number of circle is more, the student is reading. So the student is reading in a nice path, scan pathway. So based on the fixating they are fixating and the scan, that is SACARs, you can tell how they're reading or not. So eye gaze can give more information. Or I guess can give you this heat map kind of things. In this particular picture, this is mostly viewed particular place. Maybe they're reading this particular word. So this is a gaze cloud eye gaze tracker in a real time. You can try this after this talk. The gaze cloud and gaze cloud or web gazer, the two web-based eye gazer, they use our web camera to detect your eyes, and you don't need to buy any sophisticated eye tracker to do this. These are the gaze cloud ones. Okay, it can give you heat map, it can give fixations and everything. So we also have something which is a wearable eye trackers. Here it's like a pupil eye core. It has a 2 camera to detect your pupil and 1 camera for the world view, and it works better. It's not so accurate, but it works better if you're a bigger area of interest, like you're walking in the road or you're looking at a particular advertisement or not, or when you're interacting with the VR environment, or you're creating something, or you will measure it or not. Those things can be measured using VR eye trackers. And I don't know why, but let me move on. So I talked about detecting the cognitive engagement using using computer vision. Then I talked about eye gaze data. I'll just quickly go through the trace data by log data. By log data, we are able to measure the students' metacognition, and we were able to measure them with the percentage of 79%. And we actually did the think alouds and coded them and tried to measure it. And also, this is another process, metacognitive processes, which tells orientation. The planning occurs after orientation, monitoring occurs across the thing, evaluation occurs after these things. So we're able to measure it, and we compared with the 2 groups, high scorer and low scorer. High scorer is able to do planning, monitoring on the right time, whereas the low scorer did a lot of orientation. Their planning happens actually in the middle, not in the initial part of it. That's why they're not able to do it. We can understand more detail about why they, planning, monitoring, everything happens. And this cognitive engagement, like we did the ICAP, we also did create ICAP for the web-based learning environment, and that's a particular device. And you also applied this, the classroom environment, computer environment. We also extended reality environment. For example, we created this 3 Faraday's coil based on maroon wear that are simulated. We converted into virtual reality environment. Here they can move the coil, Faraday's thing, the falling coil is there. Embodied in the person become a magnet and they do it. If you see, this is the person in the behind is walking, for example, is wearing this, the head mounted VR device is a 6 degree of freedom. You can walk, move around, they are doing it. And that's the person. And we recorded all the interaction a student does in this particular VR environment and try to understand the cognitive processes. That's all the idea. And this is another video. I quickly go through it. I think we don't have time to stop here. Okay, I'll just stop here. I'll recap what we did. So the underlying goal is to understand the learning process in a different learning environments, be it a classroom, a computer-based learning environment, or the extended reality environment. To understand, we use majorly a computer vision in a classroom. And we also, in a computer vision, we use computer vision, of course, plus eye gaze data, plus the log data. That is easiest because we can collect all the data. In the extended reality, we collect only the log data. We know that Apple has come up with the fantastic device which can measure the affective states. I think it is too costly for us to buy now, but that's also a good one. We can log data, we can measure the affective states, which would tell you about learning. Why we are measuring all those things? We know their outcome. Why are we measuring all those things? The thing is that most students nowadays moving towards personalized environments or their own self-development environments, watching videos and learning on their own. When they are having trouble, and a lot of students, almost all the students register to the course with more motivation and more interest to it, but somehow they lose it. Why they are losing track? Why they are not able to understand? It's because of the patterns they are doing. Is it because of the metacognitive processes? If we can identify automatically and can provide the feedback saying that, hey, can you go and read this particular page? It would help you. Can you provide more information to them? The more personalization would help them to learn better. That's the whole goal. That is the idea of this particular the work. So the idea is to provide personalized feedback to learners by using self-regulated learning, cognitive engagement, mindset, the different terms used in the education technology. To sum it up, what we do is we try to look at the environments, computer-based classroom or the VR environment, understand the learner's interaction by using the log data or facial expressions, and understand their metacognition to provide a feedback. That is called the learning analytics definition. Learning analytics is a measurement, collection, analysis of data about the learners in the environment they are working on to understand and optimize the learning. This is called LAK, learning analytics research definition. So I just wanted to tell you, this is the whole idea about research is basically learning analytics. So yeah, I'll stop here. I know it's more than 45 minutes. I'll stop here. If you have any questions, anything we can discuss now. Yeah.
Okay, so thank you, Dr. Ramkumar. So it's now question answer time. So if anyone want to ask any question, so you can raise your hand. So one by one we can take your question. Yeah. So Dr. Nanda Kumar.
Actually, in online learning environments, the learning material is sequential in nature. Audio video form is sequential in nature.
Yes. Yes.
After doing assessment, if you're facing problem, if you're not able to understand, we want to go back to the audio video session, but to find the precise location of where we have to get the actual material is difficult. So
Yes,
if you can tag the audio video form with tags like bookmarks or something like that, and give a table of contents for the video, that will help the people easier to find where they can go.
Yes, obviously. So no, those I think I forgot to tell you. Most of our learning environments open-ended. Whenever open-ended, we give a task to them. We give the resources to the students. They can read, they can simulate, they can do. Then they have to go and solve the task. There's no end period. There's no sequential order. In that particular case, the student explores, and student first explores something, goes and tries to solve a problem. This is how the project is basically do. They open-ended. Then they go back and read it. But what you're asking about indexing, it definitely helps. It helps the students to figure out quickly. And more than indexing, we saw the students goes to particular page, spends say 3 seconds, other page 3 seconds, they skim, they search for content, then they go read for a long time. So read short, and read long, which exactly tells the scenario you mentioned. They're looking for particular content in multiple pages, then they started reading. That is also a good, ways to identify. Yeah, but indexing might work. Yeah, someone else raised hand.
Okay, so any other one? Want to ask any question?
Hello.
Yes.
Sir, one of my research scholar is working on the educational technologies for the deaf and dumb people. So,
Okay.
yeah, so basically, for the normal people, it is very easy to develop some technologies
Yes,
to
ma'am.
judge them. But for the means especially challenged people, it is very difficult
Yes.
uh, to develop the technology because lots of challenges are there. First is the communication barriers. Mostly standards are also not set in the India for some regional languages. So means we are finding very difficulties for that. So is any source where we can get some idea, means what are the different technologies are using for especially challenged people that are going on?
Uh, I think I understand your question, ma'am. Thank you. I think, but I'm not worked on any of the specially able kid or the deaf and dumb because so I can't answer the question correctly. But one of my colleague, not here, my collaborator, they're working on ADHD kid, and they are trying to understand the ADHD kids. They don't focus attention for a particular place or a particular thing for more than a few seconds. So they're trying to see which kind of agents they like it, which location in the screen they liked it. Then they try to combine that with eye tracker to see whether they are looking at it. Those kind of work is happening to understand what are they doing. Firstly, to understand what are they looking at it. Then that might be help. But honestly, I not worked on this particular field, so sorry, I'm not able to answer the question.
Okay, no problem. Thank you.
Thanks, ma'am. Yes, sir, Nandakumar, sir. Yes.
If we can actually, if we can have interactive 3D graphics material, learning material, that will certainly grasp the attention of people, and then
Yes.
continuous learning will be faster. Learning will be possible, in my opinion.
True, sir.
Interactive 3D graphics.
True, sir. Actually, see, we had a AR. I didn't show the video of AR environment. AR also VR. Also, we had the environment with 3D graphics. Even then, there are some students who are able to do well, some students who are not able to do well. So we are trying to understand what makes some students' learning process better compared to others. That is the whole goal for us now. If we're able to understand the learning process of why some are not able to do, then we could think about the methods to provide feedback or something like that. We are at the very initial stage in a class of 60, why 30 is able to do, 30 is not able to do anything. That's a goal. Any other questions?
Okay, so any other one? Sir, I have one question. As you have shown one video in the slide number 24 regarding the some backend camera, and they are getting the results sleeping and some engaged type of the activity with respect to learning outcome. For example, if some student is just writing something by using their head down, then how we can recognize that he is sleeping or just learning that one?
Yes. Okay. I think very good question. So what we did, I'll tell you one of the video, we tried to observe the students by the facial expressions. But the students' posture and the hand gesture is also important. Okay. But what really happens is we have to observe both facial expression and gesture. But in a computer-based learning with the laboratory, it's not possible for you to measure the hand gesture. Say I'm like saying this. So I'm just saying this. Why? So what is so what? But I may be looking like I am closely interested. Or I might be writing now. You might be looking at I'm writing. You might be thinking I'm sleeping.
Yes.
So these are the problem. Actually, these are the challenges. I think you asked the right question. These are challenges. It has to be addressed. The one way is to collect more gesture data, but it's not possible always. Practically, if you collect data, it's only up to this. Collect in the lab settings. So these are the real challenges, but yeah, I think we have no answers now, sir.
Okay, so maybe by fusion of the two different things, one the screen and another one is their writing or the some type of activity, then we can recognize that they are engaged or the sleeping there.
I think you are answering the thing we are doing is called multimodal learning.
Yeah,
I think.
multimodal.
One modality is expressing this particular emotion, not one modality is expressing using multiple modalities, posture, gesture, voice. Try to collect data in all the modality. That's why I didn't talk about audio. Then fuse it, align it, then you're able to detect well. That is the challenge. So even fusing or fusion of these two more channels of data is the challenge. So yeah, I think you mentioned it correctly. So it's multimodal learning analytics we do, but still we are not able to give a concrete answer. We are able to detect the emotions for all the cases. It's not possible as of now.
Thank you.
Yeah. Thank you.
Yeah. So, Chirag sir, you want to speak something?
Sorry.
You want to speak something?
Actually, I had one question, but as Ramkumar sir is saying that, actually, I have a question related to learning disability. That is just like a dyslexia, in which is that particular this type of the model. Can it be helpful, or we have to do some other method to work based on that?
I think thanks for the question again. Yeah, I'm not eligible to answer those questions because I can speculate based on the what I heard, but actually I don't have the answer. I think eye trackers and the wearable sensors and the posture sensors are the way to understand their their ability. That is the way. That is how people are doing it, but I don't have any solid conclusive answer as of now. Yeah.
Okay, so let's thank Akita Bhavija.
Good morning, sir.
Yes, you can speak. Okay, I think. Okay, so Meeta ma'am.
Yes, Manishji.
Yeah, so we can conclude the session. Can you speak something?
Yeah.
Yeah, so let's thank to Dr. Ramkumar. Now I am sharing one digital memento for him. So let's thank to Dr. Rajkumar once again.
Thank you.
So please accept this e-memento from our side.
Thank you. So yeah.
Now I am requesting to all participants, please open your web camera so that we can take one group photograph. Okay, so thank you everyone for joining this particular IEEE Educational Week Society IEEE Educational Week talk, AI in education and exploration with respect to computer vision type of thing. And in future, we will again conduct such type of the talk with respect to education activity and information on that. So let's thank you and joining for this session. Now
So next time we will plan offline mode to invite him.
Yes.
In any of our event, so just we will be in connection with him. So either in NetSIP or in any event in Ahmedabad-based region, we can have him.
Initially, I was calling Dr. Ramkumar in the offline, but he said that since the semester is going to close now, so he's very busy on the.
I would happy to come. Actually, I was going to tell that only. I would happy to come and visit the institute. It's not it's not about talk. I just love to come and visit the institute.
We will invite you in advance. We have few events in the month of August and September and July maybe. So we will.
July works, August works. I think what is happening, this is the last week of the lecture in this semester, and next week exam starts. So if we skip even 2 days, the students will, I think they will not be happy. So that's why I'm studying Institute Elective course. So that's why I just said I'll not able to come this time. Yeah.
That's good.
Dr. Ram, I have one question. Are you allowing the intern at your department?
Yes, okay. I'll just forgot to tell. We have something